Find the average of the first 64 consecutive odd numbers. Now odd numbers can be obtained using the formula 2n minus 1. That is, let us generate the odd numbers using this formula. Now the first odd number can be obtained by substituting n is equal to 1. So we have to substitute into this formula 2n minus 1. N is equal to 1, so 2 minus 1. So the first number will be 1. Let us get the next odd number. The second odd number can be obtained by substituting n is equal to 2. So 2 into 2, 4 minus 1. 4 minus 1 is 3. So that is the second odd number. To get the third odd number, we need to substitute n is equal to 3. Substituting n is equal to 3 here, 2 into 3, 6 minus 1, 5. So that is the third odd number. To get the fourth odd number, substitute n is equal to 4. So that will be 2 into 4, 8 minus 1, 7. So that is how the odd numbers have been generated. Now the first 64 consecutive odd numbers. So the 64th odd number can be obtained by substituting n is equal to 64. And that is obtained as 2 into 64, 128. 128 minus 1, you will get it as 127. So these are the odd numbers 1, 3, 5, 7 up to 127. Altogether 64 odd numbers are there. Now we need to find their average. Now this is an arithmetic progression. Every time you are adding 2 to get the next number. So in such cases, the average can be calculated as first number plus last number by 2. So using this formula, first number is 1, last number is 127 by 2. 1 plus 127, that is 128 by 2. That you will get it as 64. So average of the first 64 consecutive odd numbers, that is obtained as 64. Option C, 64. A trader has 50 kilograms of pulses, part of which he sells at 8% profit and the rest at 18% profit. He gains 14% on the whole. What is the quantity sold at 18% profit? So from one he is getting a profit of 8%. That is a lower profit. And from the other he is getting a higher profit. That is he is getting 18% profit. And overall he is getting 14% profit. So we'll find out the ratio in which he should sell the quantities. So it can be done using the mixtures and allocations formula. That is, quantity he should sell at lower profit to quantity he should sell at higher profit. This ratio is given as higher profit minus mean profit divided by mean profit minus lower profit. So let us substitute into the formula. So quantity to be sold at lower profit to quantity to be sold at higher profit. This ratio is given as higher profit is 18 minus mean profit 14 divided by mean profit 14 minus lower profit is 8. That is, in the ratio 18 minus 14 is 4 is to 14 minus 8 is 6. So you can take it as 4x and 6x. So total will be 4x plus 6x, that is 10x. And that total is 50 kilograms, from which you will get x is equal to 5. So the actual quantities are 4x and 6x. And 6x should be sold at a higher profit of 18%. So what quantity did he sell at 18% profit? That is 6x, where x is 5. So 6 into 5. So altogether 30 kilograms at 18% profit. Hence option C, 30 kilograms. A river flows from P to R. So we can draw the river like this. So P should be at the top and R should be at the bottom, because the river always flows downstream. It flows from P to R means that it has to be downstream. You cannot draw it in a V shape like this because it never goes up. Q is at the midpoint between P and R. So Q has to be here. A person can row from P to Q and back in 10 hours. So a person can go from P to Q downstream and back. Altogether it requires 10 hours. Also, he can row from P to R in 4 hours. He can row from P to R in 4 hours. So this total is 4 hours. Q is the midpoint, which means that this should be 2 hours and this should be 2 hours because Q is the midpoint. So 2 plus 2 altogether 4 hours. Earlier it was said a person can go from P to Q and back totally in 10 hours. From this information we know P to Q the time required is 2 hours. Then the time required for upstreaming has to be 8 hours because 2 plus 8 is 10. Altogether 10 hours. From P to Q is 2 hours, so remaining journey has to be 8 hours because it should add up to 10. Now we have got all the information. Look at the distance from P to Q. Now when you are downstreaming the time required is 2 and when you are upstreaming the time required is 8 hours. So if you compare the time for downstreaming and upstreaming, when you are downstreaming to the time required when you are upstreaming, the time is given as 2:8. We'll just mark it like this. That is in the ratio 2:8. That is same as in the ratio 1:4. So you can say that when you are downstreaming, you will require only 1/4 the time required for upstreaming. Which means that when you are downstreaming, your effective velocity will be 4 times that of upstreaming. That is, if one person's speed is 2 times that of another person, then he will require only half the time. Similarly, if one person is 4 times faster, he will require only 1/4 the time. So if you compare downstreaming and upstreaming, when you are downstreaming, you will require only 1/4 the time. Which means that when you are downstreaming, your speed will be 4 times that of upstreaming. So let us compare the speeds. Now when you are downstreaming, effective velocity will be B plus R. When you are upstreaming, effective velocity B minus R, and the speeds should be in the ratio 4:1. So let us solve it. I'll just cross multiply now. B plus R is equal to 4B minus 4R. So I'll just bring B to this side, so that will be 3B, 4R to this side, that will be 5R. Or B is to R, you will get it in the ratio 5:3. So find the ratio of the speed of the boat in still water to speed of the river. B is to R is 5:3, option C. A train 100-meter long passes a pole in 20 seconds. Now for the train to pass the pole, its own body length has to be moved. So distance to be moved is 100 meters by its speed is 20. So that will be 5 meters per second. So that is the speed of the train. It then crosses a 50-meter long train traveling in the opposite direction in 10 seconds. Now whether you are overtaking a train or whether you are crossing, in both the cases the total distance to be covered is the sum of their body lengths. So the first train is 100 meters long and the second train is 50 meters long. So when they are crossing each other as when they are overtaking, the total distance to be covered is 100 plus 50, altogether 150 meters have to be covered. Now here they are moving in opposite directions, so relative velocity will be the sum of their speeds. First train speed is 5 meters per second. Second train speed, will just take it as S. And the time required is given as 10 seconds. So let us just solve. 100 plus 50 gives you 150. I'll just bring 10 to this side. So 10, that is equal to 5 plus S. 0 and 0 cancels out. So what we have is 5 plus S is equal to 15, or S is equal to 15 minus 5, 10. So 10 meters per second. That is the speed of the second train, option B. Ritu's expenditure and savings are in the ratio 1:3. So you have the basic equation like this. Her total income is equal to expenditure plus savings. So if you have a income is the total money that you get every month, and some of it you will spend and the remaining will be savings. So this is the basic equation. Now expenditure and savings are in the ratio 1:3. So you can take it as 1x and 3x. Now in total income is expenditure plus savings. So 1x plus 3x, so income is 4x. So this is a basic equation that you have got now. Her income increases by 50%. So from 4x it has increased by 50%. If you increase 4x by 50%, now it will become 6x. And her expenditure has increased by 20%. So if you increase 1x by 20%, it will become 1.2x. Then what will be the savings? This plus this, totally it should add up to 6x. So this has to be 4.8x, because 1.2x plus 4.8x is equal to 6x. Now the question is, by how much percent does her savings increase? Originally it was 3x, now it has increased to 4.8x. So total increase is 1.8x. That is from 3x to 4.8x, it has increased by 1.8x from 3x. So total increase by original value into 100. This gives you the percentage increase. X and X I'll cancel out. 1.8 into 100 gives you 180 by 3. That will be 60% increase. So savings has increased by 60%. Hence option B, 60 is the right answer.